In this video, I'm gonna show you some tricks to remember basic probability formulas. Most of the time, we're gonna use the Venn diagram. For example, if you want to remember this formula right here, then we can use this diagram right here. So recall that the probability of the whole space is 1. And now A is the event right here, and A prime is the ... region. And you see the union of the two is the whole space. So that's how we have BA plus EB prime equal to 1, and that's the reason for this formula. Okay, so the next formula is this one. So if A is associated with B, then the probability of A is smaller than the probability of B. This can be seen very clearly from this diagram. So you can see here A is this circle, and then B is the outer circle, so this one follow. Now for the general addition rule in probability, then you can use this diagram to remember this formula. So here you can see that the union of the two sets A and B is this whole area together. And now A is here, and then B is here. And this is the intersection of the two. So the probability of the union, this one, is gonna be the probability of A plus the probability of B. And then when we count like that, this intersection part is repeated twice. So that's why we have a 2 minus this one. Now for the case that two sets A and B, when they are not intersect, then we're gonna have BA union B equal to BA plus BB, because the intersection here is empty. C is empty, so we don't need to recount. So now let's talk about conditional probability and related things. So this is the definition for conditional probability. The conditional probability of B condition on A is equal to the probability that both of them happen divided by the probability that A happen. So when you cross multiply this one with this one, then you're gonna have the formula right here. So sometimes you don't need to remember this formula. You can just remember this formula and derive this formula from this formula. And next, we can notice that the probability of the intersection is the product. This happens when A and B are two independent events. And when this happens, if we can consider the conditional probability of A condition on B, then we can write it down And then we see that this probability by definition is equal to this probability, and since they are independent, then this one apply, and then we have this identity. And now you can simplify this one and this one, and so you get this one left. So in summary, we have these two quantities are equal when A and B are two independent events. So in summary, the probability that A happen condition on B is equal to the probability of A if A and B are two independent events. And now we can get to the Bayes theorem, which states this. And then this is also very straightforward. So the probability of A condition on B is gonna be equal to this one right here by definition of conditional probability. And so this part right here is equal to the numerator right here. So that's how we get this quantity is equal to this quantity. So as you can see, like most of the time we can just remember like a few formulas and we can derive the rest of them.